going to work on the graphs of secant and cosecant functions, and they have been saved to last because they're actually, after you have an understanding of sine and cosine graphs, the secant and cosecant graphs are really just using those sine and cosine graphs as templates, and then we use them to be able to find the graphs of the secant and the cosecant. Because if you remember, the secant and cosecant functions are just reciprocals of sine and cosine. The sine being the reciprocal of the cosecant, and the cosine being the reciprocal of the secant. So we've got those things to keep in mind. So when we're sketching them, if you know what a sine graph looks like, or you know what a cosine graph looks like, that's going to be our starting and jumping off point. So we know that our basic sine graph looks like this. It starts in the middle, goes up, goes to the middle, goes down, goes back to the middle, and has this basic shape. I've got illustrated here 2 periods of the sine graph. And since the cosecant is actually the inverse of the sine, we can use this to find the values. First thing we need to think about is that here the ordered pairs have 0 as the y value. Okay, so it would be 0 over something. If you flip that over and try to find the inverse, then what you end up is 1 over 0. So these places right here in our cosecant graph are going to end up being asymptotes. So far I haven't graphed a single point that's on the cosecant graph, but we've got a framework going. We've got our sine curve, and we've got now the asymptotes that fit right here in those places where it would be at the middle section. So if you could please draw them in on your paper. Those asymptotes really will cross at pi and 2 pi and 3 pi and 4 pi. All of the places where you had a 0 in your sine graph will be an asymptote. So if you could please put those things in. Hopefully you have something to write with in those backpacks that you've done. And we've got that. All right, now as far as what this means afterwards, we need to think, once again, we're thinking about inverses. I don't know if you need that or not. So if we took, this is the number 1. So if you take 1 over 1, you find the inverse of 1, you still get 1. Same with -1. If you took the reciprocal of -1, you still get -1. So these points, the high points, actually belong to both the sine graph, and they also belong to the cosecant graph. So we have those points, and those are our first graph points that we have for the cosecant graph. If you were thinking about your unit circle, we know that at 0, our ordered pair was 1, 0. So when we do x over y, which is, well, when we do, sorry, we have the ordered pair 1, 0. So if we were to take and flip over that 0 point on the asymptotes, we'd get no solution. But on these, for the pi over 2, since it's the ordered pair 0, 1, 1 is our y value. Flip that over and we still get 1. And so we have those. So there's our red dots. Now the thing is that if we start to take reciprocals of these half values, like if you took the reciprocal of a half, what is the reciprocal of a half? 2. So that would bring it up here. So there's a half here, and that would take it up to 2. It's a half here, that would take it up to 2. At a fourth, what's the reciprocal of 1/4? 4, which would take it up here. A fourth would be here, would take it all the way up here. And you could do that, and as you're approaching these zeros, you're getting further and further and further up. And same down here, if we're looking at the reciprocal of -1/2, we get -2. Or -1/4, we get -4. So what you have is happening here is you've got your ones and your negative ones, but then the rest of it is a curve that goes up like this. It is discontinuous because we've got these asymptotes that we can't have values at. And it kind of almost looks like inverse parabolas, but it's not. But our sine graph is where you start with to get the framework, so you know where your bottom points and your top points are, and you know how far it can go, but your curve then goes approaching those asymptotes on the upside and on the downside, depending on where it is on your sine curve. Does that make sense? Okay. All right, so our sine curve is our framework for our cosecant graph. So what's going to be our framework for our secant graph? If we remember, we had, okay, we had our trig functions. We had sine and cosine and tangent and cotangent and secant and cosecant, and they were reciprocals like this. Okay, so the cosine is the reciprocal of the secant graph, the sine is the reciprocal of cosecant, and tangent is the reciprocal of cotangent, when we were thinking about those different values, if you remember. So we just used the sine to find our cosecant graph. We're going to use the cosine in order to find our secant graph. And if you remember, our basic cosine graph had a shape also with a period of 2, but it went like this. And then if it was to continue on for a second period, it would just keep on going like this. It's a horrible, not really neat, but if you remember from the basic ideas. So we're going to use our cosine graph in order for us to find our secant. So y equals secant of x. Where will our asymptotes be? Look at your other one. So where would the asymptotes be? It's not a 0 this time. Because it's really got to be the places where the y values are 0. So if you look at the screen for a minute, the y values are 0 here and here and here and here. So it's pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So those are all of our asymptotes. So those are all the ones where if we tried to take the reciprocal, you'd have a number over 0, so that can't be. So we have our asymptotes here. Now, once again, this is the framework of the graph. It's not the actual graph. The actual graph we'll put in solid now that we've got the framework, but our framework acts the exact same way as it did before. Our high points and our low points are these dots that we have, but then the high points continue up for our secant graph and down on this side for our secant graph, up and down, so that these pieces here in red are actually the graph. These dashed lines are not the graph, but these solid lines are the actual graph. So keep that in mind. And in your other note, make sure that you've got solid lines on the actual graph part. And then these are just these are the framework, but these should be solid right in here. And those are the actual, the graph of the secant. So when we put them side by side, once again, just like sine and cosine look exactly the same, they're just shifted over. It's the same as with secant and cosecant. The secant graph, once again, is based off of the cosine, and the cosecant is based off of the sine. Both of them have one period being 2 pi because you get a complete representation. They are discontinuous because you do have to pick your pencil up to be able to get to the next point. There's no straight line connecting them, just like in tangent and cotangent, there's no line that connects them. If you put it in your graphing calculator, it might look weird, and sometimes they put in a connection between those 2 points and makes it look like there's a straight line, but there really isn't. It's an imaginary line here in between. So when you're graphing, you use the same rules that you used for sine and cosine. You get your basic template, you throw in your asymptotes, and then you're able to finally sketch your graph. So this will be a good review of our sine and cosine graphing as well. Yes, just the red part is the graph, but you really need to have the other pieces in so that you know where the graph begins. If you don't, then you're not going to be able to have those graphs. All right, now I have another paper for you. Wait, no. On the back? Is there a back on that paper I gave you? Cool. On the back, then, we've got some other graphs to practice on. Because we need to be able, actually, I need to give you this. We have a couple more graphs I want us to graph. Not really much to this second sheet, but give you a little bit of room. So we need to go back and we need to rethink. Cosecant goes with which one, sine or cosine? Let's see. Cosecant goes with sine. Secant goes with cosine. Cosecant goes with sine, and we're trying to do a cosecant graph here. So it goes with sine. So the first thing you want to do is you want to pretend that this thing is a sine, do all the work as if it were a sine, and then you're going to put in the other values. We're going to just do one period of graph for this. So if you remember, for a sine graph, we put 1/3 x, we put whatever is here between 0 and 2 pi because that's a complete period. So we're going to go ahead and do that. Okay. Putting 1/3 x between 0 and 2 pi because our one complete period goes from 0 to 2 pi. And when we multiply everything by 3, that gives us 0 to 6 pi is our one complete period. It stretches it out over that whole thing. When we do our work to find the middle points, if we add 0 plus 6 pi and then multiply it times a half, you get 3. 0 plus 3 times a half is 3 halves. 3 plus 6, 9 times a half is 9 halves, all in terms of pi. And then we had our 2 right here, 2, meaning that our amplitude is 2. We want to go back to this idea of amplitude that we had in our sine graphs. I'm going to take this. There's way too much just. way too much on there, so we're gonna do this from scratch on a nice clean piece of paper here. There we go. So what I want to do is I want to take a look. I want to pretend that I'm graphing, so you can go ahead. We're going to pretend that we're graphing a sine graph. So we're going to go right across here. Our amplitude is going to be 2. So we want to go, we're going to do 2 lines up. I'm going to go ahead and make it like a skinny line so we can see. Oops, I don't want that one to be a skinny line. This one to be normal. I want the next one I draw to be skinny. So I want to do it. I want to make my amplitude 1. And I want to make another one. So there's 2. 2 up, and we're going to go 2 down. So you should be drawing this right along with so that you can follow everything. Like this. So what we've got here, we've got 1, 2, -1, -2. And then for our graph, we're trying to go all the way from 0 to 6 pi. So what I want to do is I want to make some nice lines here. I've got 1, 2, 3, 4, 5, 6 pi. And we know 3 pi is also important. 1 pi, 2 pi, 3 pi. Here's important. Here's important. We also said 3 pi over 2. As a mixed number, 3 pi over 2 is really how much? As a 1 1/2, right? So here's 1 1/2. Here would be our 3 pi over 2 mark. And then right here would be our 9 pi over 2 mark. Now, like I say, we're trying to make our templates here before we actually even do our cosecant graph. I might actually need a little bit more space. Because remember, these things are going up and down. So put a little more space at the bottom. Okay, so if we're just thinking sine for a minute, remember we start at 0, and then we go up. And then we go to 0, and we go down. And then we go to 0. But this time I'm going to make a nice dashed line because it's not really our graph. This is just our template so we know what's happening. What will be our next step now that we've got our ghost sine graph? Asymptotes, good. And the asymptotes go where? 3 pi and 6 pi. So I've got my one that goes like this, my other one that goes like this. And what we can do is we can make it dashed by just erasing a little bit. Now you'll use different things. You might just flat out draw dashed lines. That's fine. This is just a little bit easier this way. So I've got the asymptotes, but then the numbers that are actually part of the graph are right here and right here. And after I've got those 2 points, what do I do to finish it off? Good. So you do the opposite. You do the like this, up like this. You can just sketch it in like I'm doing. It's fine. I will be looking definitely for the high point. I'll be looking for the asymptotes to be drawn in correctly. I'll be looking for the low point, and I'll be looking for the asymptotes to be drawn in correctly. And then I'll be looking to make sure that it's curved rather than straight. The asymptotes, yes.
No,
Like these. It's helpful for you to not get lost in the whole process.
Oh, for sure.
But if you had everything drawn right and your ordered pair was exactly right, like 3 pi over 2 to 2, 9 pi over 2 to negative 2, and then you had those, and you had your asymptotes drawn in, that's fine. Make sure your asymptotes have dashed lines, not solid lines, because that's important. So we've got that. And then this is the one you come up with if you spend a little bit more time on it rather than, here we go. So it looks very nice like that. There's your actual graph is these solid pieces right here. And so we're going to do the one more that I've got on the sheet. The secant. So the secant is going to be based off of which graph? Cosine, good. So it's based off of cosine. So let's do this beginning to end. We're going to go ahead and put this on a nice clean sheet. Okay. And so what would our first thing be to do for this?
Draw the graph.
Well, the first thing can't be to draw the graph because we don't really know what we're expecting yet.
Oh, for sure.
Now we said we're basing it off of the cosine graph, so we'll just kind of make a little note for ourselves there so we don't forget.
Oh, yeah.
Did you say sine?
And then you're like, yes.
Oh, okay. Well, okay, so I thought I was paying attention. So secant goes with cosine. Secant goes with cosine, so let's correct that. Sine goes with cosecant, so we've just got to be careful, and I'm glad that you brought that up. I'm sorry, I heard in my mind the correct answer, so I apologize for that. No, I wasn't paying attention as closely as I should, so that's a problem for me. Here we go. So first thing we do, if we're going to do cosine, this part goes between what and what? 0 and 2 pi. Because on sine and cosine both, the initial period is from 0 to 2 pi. So then what we need to do is we need to find out our beginning and end points. We can do that by adding our pi over 2. This will be good for everybody because that sine and cosine are going to come back on your test anyway, so we may as well review all of that right now. So our new period is from pi over 2 to not exactly 3 pi over 2. How about 5 pi over 2? Because this is 4 pi over 2 plus 1 pi over 2, 5 pi over 2. Okay, so now we need to find our middle. We need to find those middles. So just to review that process, we add these two together. Pi over 2 plus 5 pi over 2. And then multiply by a half. That gives us 6 pi over 2 times a half, which actually gives us 3 pi over 2. So far we've got pi over 2, we've got 3 pi over 2, and we've got 5 pi over 2. But then we need to find this one. This one, you take pi over 2 plus 3 pi over 2 times a half. Now some of you, just because you've got good number sense, you're not actually doing this whole process, you're just finding the average in your head, which is great. But just in case you need a process, 4 pi over 2 times a half is actually just pi. And then right here, 3 pi over 2 plus 5 pi over 2 times a half gives us 8 pi over 2 times a half, which gives us 2 pi. So our important numbers here, right here. I'm just going to take this and put it in a nice clear spot for us. We're going to copy that, put it on a new page. Okay, so we've got our key points here, and we can start to graph it. Okay, so we do have a magnitude to think about. We've got this -1/2 to think about, but we can start off with our x and y. And then we can move right along, and we can do our up to 1. To be smaller. We can go down to -1. Nice and neater a little bit. There we go. So we've got our 1, we've got our -1. We've got to go from, we've got to go pi, 2 pi. Here's our pi. And here's our 2 pi. I'm going to go to a 3 pi also. But then we've got to get our other ones. We've got to get our pi over 2. Our pi over 2 belongs here. We already have our pi. Here's our 3 pi over 2. Here's our 2 pi, and here's our 5 pi over 2. I just have the 3 pi here for context. It's really not going to be important for what we're doing for our 1 period. Nice. Large pen now. All right, we still need to actually think about what the cosine would look like. We need to take into account this -1/2. So what does -1/2 do for us? First of all, it changes our amplitude, right? So our amplitude now is not up to 1 and down to -1, it's up to where? Up to 1/2, thank you. And down to -1/2. Now our cosine would normally start up, and it would start at our first thing. This would be up, but since it's a negative, we're starting down. And just to remind you, the next place you would go would be the middle. And then you would go up, and then you'd go to the middle, and then you'd go down. And here we've got our nice, this would be our 1 period for that cosine. We need asymptotes though, because we now have to shift our gears into thinking about secant. Where will the asymptotes go? At what values? Will be at pi over 2, pi, 3 pi over 2, 2 pi, or 5 pi over 2. What do you think? What do you think? Where's the asymptotes go?
Pi and 2 pi.
Pi and 2 pi, thank you. We've got pi, we've got 2 pi. Okay, so we've got our asymptotes. Once again, these are dashed because they're not really lines in the graph, they're just for getting shape. But once again, we take our high points and our low points are actually part of our secant graph, and then down we go. And then here we go up on this side, and we go up on this side, and we go down on this side. And then we've got our brand new secant graph are these red pieces right there. And so that's the process. It's really not that much more than just knowing how to do the sine or the cosine graph, and then you're just modifying it to be able to get those things in there. So as I said, we're going to work today. We had this lesson today. We'll work on the assignment today. We'll work on the assignment tomorrow. You might not actually have to take it home. And then on Monday, we'll work on going over everything, making sure that you've got your quiz all taken care of and reviewed. And then you'll have a review assignment that you're going to have due on Tuesday, number 64. And then Wednesday would be your chapter 17 test. And that's pretty much it.